Ever get this, like, almost eerie feeling when you look up at the night sky? Like, it's beautiful, sure, but also kind of unnerving.
I know exactly what you mean. It's that vastness, right? Makes you feel pretty small.
Exactly. And what's even wilder is that most of what's OUT there,
Mhm.
we can't even see it. Dark matter.
And the article you've brought in today, well, it dives into a possibility that's almost more unsettling than just not knowing what dark matter is.
It's the idea we might never actually figure it out.
Exactly. Which would mean there are some fundamental things about physics, about the universe itself, that we've gotten wrong.
So, for folks just tuning in, can we do a super quick recap? Like, why do we even think dark matter exists?
It all boils down to gravity, really. Think of it this way. We see the way gravity affects things, right? Galaxies spinning way faster than they should based on the stuff we can see.
Right, like there's something there, some invisible mass with extra gravity.
Precisely. And it's not just galaxies either. The way they're clumped together, how light bends around massive objects, it all points to a lot more stuff out there than we can directly detect. That's dark matter.
Okay, so we see the effects, but not the cause. But here's the kicker. We've been searching for this stuff for decades. Haven't found it.
And that's where the article gets real interesting. Because maybe it's not just that our instruments aren't good enough yet.
You're saying, what if we're fundamentally misunderstanding something?
It's a scary thought. What if dark matter isn't made of particles like the ones we know? What if it interacts with the universe in ways we haven't even considered?
So it's not just about filling in a blank spot on our cosmic map.
It's about whether we're even holding the right map to begin with.
Okay, now that is a mind-blowing thought. If we're that wrong about dark matter, what else might we be missing? Makes you realize how much we don't know.
Exactly. And that's what makes this search, successful or not, so important. It could completely reshape our understanding of the universe and our place in it.
This is already fascinating, and we're just scratching the surface. So let's get into the nitty-gritty. What are the big theories out there, and how close are we to proving them? Or disproving them, I guess.
So one of the big contenders, for a while anyway, was this idea of WIMPs.
WIMPs. Okay, gotta admit, that name doesn't sound very intimidating for something that makes up most of the universe.
Right. But it stands for weakly interacting massive particles, meaning heavier than anything we've detected, but they barely interact with normal matter. Like, imagine trying to catch a shadow.
Okay, yeah, that's starting to sound a little more mysterious. But if they're so hard to catch, how do we even know to look for them?
Well, for a while, they fit in really well with another theory called supersymmetry. Without getting too deep in the weeds, it suggests every particle we know has a heavier superpartner.
Okay, so finding those would be a huge deal.
Huge. It would explain a lot, not just dark matter, but some other things physicists have been puzzling over. And for a while, there were hints, like this thing called the galactic center Jeve excess.
Catchy.
Tell me about it. Anyway, turned out there were other explanations for that signal that weren't quite as exciting.
So is supersymmetry dead in the water? What about WIMPs?
Jury's still out, honestly. We haven't seen evidence for those superpartners yet, despite building bigger and better particle colliders. But maybe we're just not looking in the right way. It's like we built a net to catch an elephant, but maybe dark matter is more like a school of tiny, super fast fish.
Okay, I kind of love that analogy. And speaking of things that are hard to pin down, the article also mentioned axions. What are those?
Oh, axions are where things get really weird, even for physics. Imagine something so light it acts more like a wave than a particle.
Wait, I thought those were like quantum physics things. Particles being waves, too.
Exactly. It's one of those mind-bending things about the universe. And axions, if they exist, would be everywhere. This constant faint wave passing through everything, like trying to detect a single ripple in the ocean.
Sounds impossible.
Almost. But the really cool thing is we're now at a point where our instruments are getting sensitive enough that we might actually be able to pick up on those faint signals.
So there's hope yet. But even if we find these things, WIMPs or axions, the article seems to say that's not the end of the story.
Not even close. Those are just two of the most popular ideas. But there's a whole world of other possibilities, some even weirder than those, that might be contributing to this cosmic mystery.
It's like we've been playing checkers, and suddenly someone's brought out a whole chessboard we didn't even know existed.
That's a great way to put it. The article really drives home this point that WIMPs and axions, they're just the tip of the iceberg. There's a whole universe of other possibilities, and some of them are, frankly, kind of terrifying.
Terrifying how so?
Well, take the idea of dark sectors. Imagine entire realms of particles and forces completely separate from the ones we know, like Our universe is just one tiny bubble in a much bigger, weirder reality.
Okay, that's definitely more Stranger Things than I was expecting from a physics article.
Yeah.
But so, how do we even begin to wrap our heads around that? What could these, like, dark sector particles be like?
That's the million-dollar question. We're talking about stuff that barely interacts with our universe at all, if ever. It could be anything, really, and that's what makes it so exciting. It's like we're not just searching for a new particle, we're searching for a whole new set of rules for how the universe works.
So it's not just about finding a needle in a haystack. We don't even know what the needle looks like, or the haystack for that matter. But the article did mention something else. Machos.
Ah, yes, the machos.
Yeah.
Always a crowd pleaser, that name.
I mean, it sounds kind of cute for something that could rewrite physics as we know it.
Right. Don't let the name fool you. Massive, compact halo objects. We're talking primordial black holes, maybe even things left over from the very beginning of the universe, so dense they're almost impossible to see directly.
So instead of tiny elusive particles, it could be these, like, cosmic behemoths lurking in the shadows.
Exactly. And there could be a whole lot of them, too. Enough to account for that missing mass, that extra gravity we see from dark matter. It's a pretty wild thought.
Wild is definitely one word for it.
Yeah.
But if we're being honest, it all seems so overwhelming. Like, if dark matter could be any of these things,
Yeah.
or something else entirely, how do we even begin to search for it?
That's the challenge, isn't it? It's not enough to just build bigger detectors anymore. We need to completely rethink how we approach this problem. Start asking different questions, be open to possibilities we haven't even considered yet.
So more like exploring uncharted territory rather than following a map.
Exactly. And who knows, maybe the most exciting discoveries will come from those unexpected detours, those moments when we realize we were totally wrong about what we thought we were looking for.
I love that. Sometimes not finding what you expect is even more rewarding than finding it. And in a way, that's what this whole deep dive has been about, hasn't it?
Absolutely. It's about embracing the mystery, acknowledging that we don't have all the answers yet. And honestly, if we did have all the answers, wouldn't the universe be a lot less interesting?
Way less interesting. There's something really exciting about knowing there's still so much out there to discover. So, to everyone listening, keep looking up at the night sky and asking those big, impossible questions. Who knows what amazing things we'll find when we least expect it. Until next time.